Under the one, yeah. What the? Bond. Good afternoon. Can you hear me? Okay. Okay, let's start then. Okay, so today we will start with the new unit, kinematics. New unit kinematics, which I have already told you is the study of motion. Okay, study of motion is called kinematics, and inside this we will be doing the chapter motion in a straight line. Okay, this is the chapter that we are going to study today. Okay, so before that I have to teach you a little bit of mathematics that we are going to use later on, and those two are uh, topics of calculus. Okay, calculus is a branch of mathematics which you will be learning in class 11 and 12. So I'll just give you a brief introduction on calculus, and two things I'll teach you today, that is, one is differentiation and integration. Okay, these are mathematical tools. Okay, these are mathematical tools that helps us study physics, and physics is a lot of mathematics, so that's why also we need this differentiation and integration. Okay, so first we'll start with differentiation. Any doubts so far? Any doubts so far? Any doubts so far? Any doubts so far? Good afternoon to everyone. Yes, and if you have any doubts, please write down in the comment box. If you don't have, also please say that it's clear, so that we can move faster. Okay, so yeah, so differentiation. Okay, so we will be learning first differentiation. So what do we do in differentiation? We study how one quantity changes with respect to with respect to the other. Okay, suppose we have two quantities x and y. Suppose we have two quantities x and y, these can be anything, and there is a formula that links them. Suppose x is y is equal to x square plus 1. Okay, there is this formula that links them. Understand? Now if I draw a graph between these two, let us draw a graph. Okay, so suppose this is y along this axis and this is x, and if I draw a graph using this mathematical formula, then I'll get a graph that looks something like this. Okay, this is the graph that I will get maybe. Okay, understand? For now, just try to understand. So this is the graph that we get, right? Okay, let me draw it with a so this type of graph I'll get. Okay, if I draw this mathematical formula. So now differentiation helps us to understand how your y will change if x changes. Suppose there is a change in x becomes x dash. What will happen to y? Okay, if you want to study that, you have to study differentiation. Differentiation will answer that question. Okay, understand? So let us take 2 points, right? This is 1 point here, this is 1 point here, right? So definitely at these 2 points you have two different values of x, right? The value here may be x1 and the value here may be x2, right? So that means x changes from this point to this point. Yes, x changes from this point to this point. So in the same way, since y is related to x, right, there is a formula that links them, so definitely y will also change. If x changes, y will also change, right? So you can answer the question how y will change when x changes if you use a differentiation on y. Is it clear? Let me give you a simple example. Suppose the value of x before is x, like suppose the value here is x and the value here is x plus h, where h is a very small number. Okay, h is a very small number, so that means the new value of x is x plus h. So this is the original value, this is the new value. What will happen to the value of y? So for that, what we can do, we can let us call, so okay, when x is this, let us say the y is, when x is this, let us say y is y dash, right? So what will be y dash? Y dash is that. So now if you want to see how y changed with respect to x, delta y by delta x, okay, then you will write y dash minus y divided by h. Okay, this delta, what is the meaning of this delta? I think I have explained this, or if I have not, then just remember this delta means a change in y, change. So since I have written delta y, it means change in y. Similarly, delta x means change in x. So how delta y changes when x changes, this what I am writing here, you should read it as how your y is changing with respect to how your x is changing. Okay, so I am just doing what? Final. This is the final value, right? This is the final value here. The value, this is the value here, right? This is the value of y here, y dash, and this is the value of y here, y, right? So this is the final minus initial divided by how much is the increment. Increment means how much did x increase. Okay, understand? I hope it's clear. You can even write this as x plus h minus x. You will get h only in the end, so that's why. Okay, I have not written anything there. Okay, so this way you can find out how your y is changing with respect to x. Now suppose, now suppose you want to make this h very small, you want, so you can see the gap here is quite large, right? I am taking the one value here and another value here, right? So it's quite large. So suppose I want to know what happens to y at this point, at exactly the next time, right? Suppose okay, again I'll start from here. Let us say time here is let us say time here 2 second, time here is 6 second. What is the gap? The gap is 4 second, right? So that's quite a big gap. So suppose you want to know what happens at the next second. What happens at the next second? That means after 3, so this is 2 second, what happens at 3 second? So in that case your x will increase, but by a very small number. The h will be very small, right? So to show that, we put limit. Again, this limit thing you will do in mathematics. For now, just understanding what is the meaning of a limit. Limit means you are putting a, that means you are using, or you are trying to put a limit on the value of h. You are trying to put a limit on the value of h. You are saying that h should not be very large. So let us say h is very close to 0, right? H is very close to 0. Now close to 0 can be 0.0001, it can be minus 0.99, right? It can be anything, understand? Okay, so close to 0 means it can be any value very close to 0, understand? Okay, so to do that, so this is what we get in that case, this y dash, so y dash minus y divided by h, right? So if I put a limit on this, then this delta can be replaced with dy dx. So this is differentiation, understand? This is the concept of differentiation, okay, understand? D again, so see delta, when I write delta and when I write d, what is the difference? When I write delta, that means the change is quite large, okay, it's quite large, and we can use simple subtraction addition to find the answer. But when I write d, that means the change is very small. The change is very small, that means your x changes by a very small amount, okay, that's why I have written d, okay. So this is a, so dy dx, this is a mathematical tool, to study how y changes when x changes, okay. This is a mathematical tool, understand? So far any doubts? Tell me if you didn't understand, tell me. No means what? No means no doubt, or not clear? What does it mean? Okay, explain again. So okay, so differentiation, what is differentiation? Differentiation helps us to study how one quantity changes with respect to another. Suppose there is a relation between two quantities. Let us say the two quantities are x and y. This can be anything, okay, we will see that later. This can be anything. For now, just understand that they are some quantity. It can be force, it can be velocity, whatever, right? Okay, so there is a relation between them, maybe something like this. The relation can be anything, but just for example I have taken this, okay. So y is equal to x square plus 1. So now you see that if I change the value of x, y changes, right? If no matter, if I put 2, if I put x equal to 2, I will get y equals to 5. If I put x equal to 3, I will get x equal to y equal to 10, right? So that means y changes when x changes, right? Y changes when x changes. So that's what differentiation does. It helps us to study how it changes, okay. Let me give you a simple example. Suppose you have a wall, okay. This is the wall of your house maybe, Suppose this is the wall of your house and you have a ladder here. Suppose you place a ladder on this wall like this. Right, there is a ladder here. Okay, this is a ladder that you have placed on the wall, right? So there is a this distance, let us say it is x, and let us say this distance is y. Okay, now suppose you change x. You change x means you place the ladder somewhere else. Maybe now you place it here. Okay, I'll draw another diagram. Just wait. Okay, so initially the ladder is here, right? So this is your x and y. This is your value of x and y. Now next time, suppose you place this ladder here, right? You place the ladder here. What will happen? The ladder will rest somewhere here. Yes or no? Right? Understand? Now the new value of x will be this. This will be your x dash, let us say, and the new value of y will be this, which is y dash, let us say. Okay, x dash, y dash. Understand? Now look here, what is happening when x changed, y changed? Yes or no? When x changes, y changes. Are you seeing this? Yes. So this differentiation, when I write dy dx, this helps us to study how y is changing when x is changing. So when I changed by a small value, let us say I changed by 1 centimeter, what happened to y? How much did it change? So that you can answer by finding this value. And how to find this value? You can use this formula. This is called derivation by first principle. Mathematics part, don't worry about it, you will be doing in maths. For now, just understand what is the meaning of differentiation. Differentiation means studying how one quantity changes when the other is also changing, right? In this case, the one that is changing is x, right? And we are trying to study what happens to y. Okay, so that is differentiation. That is the process of differentiation. Is it clear now, or still you have doubts? Clear to everyone? Okay, so that is your differentiation. Understand? So let me give you an example. So dy dx. Now I told you this y and x can be anything, right? So let us say y is displacement. Y is displacement or position. Let us say y is displacement or position, and let us say x is time, right? X is time t, y is displacement s. Understand? Then in that case the formula will be ds dt, right? So what is the meaning of this? Change in position with respect to, WRT means with respect to time. Change in position with respect to time. This is how we'll read this. ddt of s, ddt of s, right? Differentiation of time with respect, differentiation of displacement with respect to time. Okay, there are many ways of reading this. You can say differentiation of position with respect to time, or change in position with respect to time, or ddt of s. You can say that. Okay, so now if you remember from your smaller classes, what is change in position by time? This is velocity, right? This is velocity. Understand? So that means, see, if there is a formula I know, suppose s is equal to t cube plus t square plus t plus 2, right? Suppose this is the formula between displacement and time. That means after a time 1 second, displacement will be something that we use and we can use this formula, right? In that case, I will put this value here and I can find the velocity also. Okay, so that way your differentiation helps you. So I will give you some easy formulas for differentiation that you must remember. There are plenty. Okay, there are many formulas for differentiation which you will be doing in maths, but for physics you will not need much. So one is ddn of dx. Suppose ddx of x to the power n. Okay, this is n. So dd, so what will be the formula? Formula is n x to the power n minus 1. This is the formula. Understand? Now let us say ddx of constant. Okay, constant means any value which does not change. In that case it will be 0. Okay, some more formulas. ddx of 1 by x, this is log x. Okay, logarithm I hope you have done in maths. Okay, if you have not, then you will learn about this, but just remember the formula for now. ddx of 1 by x is logarithm, sorry, the opposite actually. ddx of logarithm of x is equal to 1 by x. Understand? So these are some formulas that you will need when we study this chapter. Okay, understand these formulas. So let me give you an example on this. Let us say n is 3. Let us say n is 3 here. So what will I get? ddx of x to the power 3. What will I get? 3x square. Okay, using this formula. Understand? Suppose I tell you find ddx of 3. Now 3 is a constant which does not change value. So using this formula, answer will be 0. Okay, that way. Is it clear? Yes or no? Is it clear? Yes or no? Is it clear? Okay, so that is differentiation. Understand? Now next thing that we will learn is integration. Integration. Okay, another tool. This is another mathematical tool. Integration just from the word itself. Integrate means to add up, right? Integrate means to combine or to join or to add, right? So that is what integration does. It adds up small quantities that can help you to find another quantity, right? For example, let me give you an example. You know the formula for work done. Work done formula you must have done before also, that's why I am using this. Work done is force into displacement, right? This is the formula for work done. Okay, this is the formula for work done. Now let us say we have a small setup and we have a box here, right? And there is a force acting on this, right? There is a force acting on this. That force, let us say it's F. F is a force that is acting on this box, and because of this force the object now reaches here. Let us say it reaches here. Okay, because of the force object reaches here. Okay, somewhere here. Now so let us say this distance is x, this distance is x, let us say. Okay, so how much work, okay, let us say you are the one who is doing this, you are the one who is pushing the using the force to push the block, right? So how much work did you do to move the block from this position A to this position B, right? How much work did you do? You can easily find it by putting the formula for the force and the formula for displacement, right? Displacement means this distance. Okay, so you can easily do that. But suppose one condition is that the force is changing, the force is not constant, the force changes with time, at this position it is something else, at this position it is something else, at this position is something else, right? In that case, what will you do? Can you directly put the formula? No, you cannot directly put the formula. In that case, what you will have to do, you will have to find small work done first. You have to find the small work done. So first, maybe till from here till here you are pushing with the same force, right? You are pushing with the same force. Then what will you do? You will take that force, multiply it with that displacement. So let us say you are pushing with force F there, and you moved it by a distance dx. Okay, you moved it by a distance dx. Now again, next thing you will do again. So here maybe the force changed. It became F1. So now it will be F1. It will be F1. Again, let us say you moved by a distance dx. So dx again. In that way, same way, d3 f3 dx, right? So that way you will go on adding till you reach b. You will go on adding till you reach b. So this you can also write with summation, right? You must have seen the symbol in statistics in class 10, summation, right? So you can write I1 to let us say n fi dx, right? This is the way of writing this. Let us say so f n dx, right? So let us say the force changed how many times? N times, right? Let's start 1 2 3, right, like that. Okay, so 1 2 3. So the force change n times. So that this way you can find the thing, right? Are you understanding or no? Are you understanding or no? Are you understanding? Yes, okay. Understand? So that way you can do, you can use the summation to find the total, right? So this you must have done in statistics, right? What is the meaning of the symbol? That means first you'll put I equal to 1, so f1 dx, then you'll put plus sign. Summation means summation. Summation comes from the word sum, which means to plus. So to expand this, first you have to put the value of I, which is 1, then you'll put the plus sign, then you put the next value of I, which is 2, so f2, then you'll put the next value of I, which is 3, like that, with plus sign separating them. Understand? So what does integration do? Integration can replace this summation. Integration can replace this summation when the values are very, very small, right? For summation there is a problem that you cannot take very small values. Suppose the values that dx changes takes is very, very small, right? In that case summation will be very difficult. So that what we do, for that we replace this with this symbol with this symbol, right? We replace the summation symbol with this symbol. Okay, this is the symbol of integration. Understand? Symbol of integration, this way. Okay, understand? So in that case, what will I write? F dx from, let us say this is x1, this is x2, from x1 to x2. Understand? From x1 to x2. Is it clear? Is it clear? So this way integration can help us, right? Understand? This way integration can help us. Is it clear? Is it clear? Yes or no? Anyone, any doubts? Okay, understand? So that is the that is the function of integration. It helps us to integrate things when the things that you are dealing with are very, very small, right? So now again, so this is an example that I gave. It can even be displacement. It can even be suppose you put vi t, vi, v and t, right? Suppose you have v and t dt, sorry, just a minute. So it can even be v dt, right? Now v is velocity, t is time. If you multiply velocity with time, you get displacement, right? So integration can even help you find the displacement. Let us say the initial velocity is va and final velocity is vb, right? Okay, so here this can be f1 also, right? So it can be these two. Understand what I'm saying? Understand or not? So integration can help you find displacement also, right? By using, suppose your velocity is changing, there is an object moving like this, right? Anyway, and its velocity is changing continuously with time. So and you want to find the distance that it has moved, how much distance did it move? So you can use this formula, right? Understand? You have to take a small value of v dt first and then integrate it from smallest va to maximum vb. Understand? Maximum value of velocity to smallest value of from smallest value to maximum value of velocity. Is it clear? Is it clear? Is it clear? Yes or no? Integration, differentiation, integration, is it clear? If it's not clear, just tell me. Okay, understand? So that is a thing, but you don't worry about this. Again, you'll study integration in class 12. For now, just understand, when we use it later on, I will use some reference from here. That's why it's better you know a little bit. Okay, so that is differentiation and integration. Okay, okay. So some very simple formulas. Let us say you have x to the power n, and you differentiate it, then you integrate it with respect to dx. What is the formula? Formula is n plus 1 divided by n plus 1 plus a constant. Okay, whenever you integrate a quantity without putting the limits, these are called limits. This va, vb, f1, f2, these are called limits. Without putting the limits, if you integrate a quantity, you will get a constant. This is called constant of integration. Constant of integration. Constant of integration. Is it clear? Understand? So these are some small formulas. Another formula is integration of 1 by x dx. What will we get? You will get log x plus c. Understand? So these are some values. Others we will I will give you a screenshot on them. Okay, understand? Now look at these, look at this one. Integration of 1 by x dx is log x, whereas differentiation of log x is 1 by x. Do you see? They are exactly reverse of one another, right? If I differentiate log x, I get 1 by x. If I integrate log x, I get integrate 1 by x, I get log x. Can you see that they are reverse? So integration is like the reverse of differentiation. Is this part clear? Okay, integration is like the reverse of differentiation. Is it clear? Has anyone any doubts? Please write in the comment box. Anyone any doubts? Okay, there is some problem in the computer. I'll just reconnect. Okay, you please join again. I will send you the link once again. You please join. Okay, is it clear? Okay.